Assalamu alaikum students. Up till now we have learned about salts, their introduction, their solubility rules, what type of salts are soluble, what types of salts are insoluble, and their method of preparation. Now we will learn how to identify a particular salt. So in this topic we will learn what is meant by qualitative analysis, and in today's lesson we will particularly focus on analysis of cation, that is positive ion present in a salt, how cation analysis is carried out, and what reagents are used for cation analysis, how they react with the cations, and what are the visual observations. So let's start with the qualitative analysis. What is qualitative analysis? First thing that you all know that all salts are ionic compounds. It means they contain positive ion that are cations and negative ion that are anions. So the process of identification of cation and anions is known as qualitative analysis. In today's lesson we will focus on analysis of cation that are positive ion. So here is a tip. In order to identify an unknown salt, it must be dissolved in water either at room temperature or on heating. Let's discuss how to identify cation. The first thing is most cations give precipitates with alkalis. Obviously not about sodium, potassium or ammonium ion. They do not give precipitates. What are precipitates? Insoluble salts. Do you remember we have already studied the precipitation with alkalis in the topic of alkali. We have studied that an alkali reacts with another salt to form another hydroxide that is precipitated out. A cation can be identified by noting the following: the color of the precipitate produced, whether the precipitate is soluble or insoluble in an excess of an alkali, and ammonia gas is liberated on addition of sodium hydroxide solution or not. So these are the three hints that we can use to identify any cation present in a particular salt. So here is the list of cation that are present in your syllabus. These are not 3, 4 of cations are ahead. So how do we come to know? Here we are using alkali is sodium hydroxide. So we will observe by adding few drops of sodium hydroxide solution in the solution of that particular salt, and then by adding excess of sodium hydroxide. If on adding a few drops of sodium hydroxide solution white precipitate is formed, it means the salt may contain aluminium ion. And by adding excess of sodium hydroxide, if that precipitate dissolve and give a colorless solution like this, it means that aluminium ion is confirmed. By adding ammonia, a few drops of aqueous ammonia, white precipitate is formed. The salt may be having aluminium ion, and if that precipitate is insoluble in excess, then it means the aluminium ion is confirmed. In case of calcium ion, also white precipitate is formed by adding few drops of sodium hydroxide, and by adding excess of sodium hydroxide, that white precipitates are insoluble. So here is the difference between aluminium ion and calcium ion, that in aluminium ion white precipitate dissolve in excess, but in calcium ion white precipitate is insoluble in excess. On adding aqueous ammonia, calcium ion do not give any precipitate and there is no reaction, either aqueous ammonia is added in excess. White precipitates may look like this, cloudy one. In case of copper ion, on adding few drops of sodium hydroxide, a light blue precipitate is formed. You can see light blue precipitate, it's of sky color. And by adding excess of sodium hydroxide, the precipitate remain insoluble. So what will happen when we add a few drops of aqueous ammonia? Light blue precipitate is formed, but the precipitates dissolve in excess and give a deep blue solution like this. Is it clear? The next cation is ferrous ion, iron having oxidation state 2 positive. So in case of ferrous ion, on adding few drops of sodium hydroxide solution, we will get green precipitates. You can see green precipitates over here. On adding excess of sodium hydroxide solution, the precipitate remain insoluble. And same is the case when we add a few drops or excess of aqueous ammonia. Ferric ion, when we add few drops of sodium hydroxide, it gives reddish brown precipitate. You can have a look on reddish brown precipitates. And by adding excess of sodium hydroxide, the precipitates remain insoluble, and same result when adding a few drops of ammonia or excess of ammonia. In case of lead ion, by adding few drops of sodium hydroxide, white precipitate is formed, but the precipitate dissolve in excess and give colorless solution. In case of lead ion, by adding few drops of aqueous ammonia, white precipitate is formed, but in excess the precipitate remain insoluble. You have to remember this test. Zinc ion, by adding few drops of sodium hydroxide, white precipitate is formed, and the precipitate dissolve in excess of sodium hydroxide solution to form a colorless solution. And same is the case when adding few drops or excess of aqueous ammonia. In case of ammonium ion, obviously we cannot test ammonium ion by adding ammonia. In case of ammonium ion, no precipitate is formed when we are adding few drops of sodium hydroxide solution, but on heating, ammonia gas is given off. And how can we test ammonia gas? Ammonia turns moist red litmus paper blue. So when we will bring moist red litmus paper near the mouth of test tube, it will turn into blue because ammonia is an alkaline in nature. So here we will discuss what are precipitates. The precipitate that we are saying that these are formed when adding aqueous ammonia, these are formed when adding aqueous sodium hydroxide. So what are basically these precipitate? As we have already studied in the method of preparation of salt, that the precipitates mean insoluble solid. It means that solid forms is insoluble, but that is the hydroxide of the metal ion. The precipitate in each of the reaction is the hydroxide of metal ion. For example, reddish brown precipitate in a solution containing ferric ion is ferric hydroxide. Ferric hydroxide. Ferric ion plus hydroxide ion, they will form ferric hydroxide. These are of reddish brown precipitates. And some of the precipitate dissolve in excess sodium hydroxide or aqueous ammonia. Why does it so? Because it will form a compound that are soluble in water. By adding aqueous ammonia or excess of sodium hydroxide, a compound is formed that is soluble in water. Therefore, it will form a colorless solution or a clear solution. For example, solution containing zinc ion or copper ion, on adding excess of sodium hydroxide or excess of ammonia, it will form a water soluble compound. This was about the identification of cation. What you have to do, because this qualitative analysis is very important for paper 4. Here you can see there is a question number 4 of October-November 2019, paper 4-1. This is of 10 marks. A student is provided with 3 solutions: aqueous zinc sulfate, aqueous copper sulfate, aqueous calcium nitrate. Here the 3 solutions are listed. Student test the 3 aqueous solution by adding each reagent shown in the table. Here are the 4 reagents. Record the observation in the table. Now you have to learn these observations what you have studied. So you have to fill first 2 columns, because we have studied the identification of cation by adding aqueous sodium hydroxide, few drops and in excess. So you have to fill these 2 columns by remembering the cation present in these salt. The rest of the 2 columns we will discuss in next lesson, and we will fill these columns in the next lesson.